Good afternoon, everybody, and welcome to the afternoon session in rooms 120/122. My name is Phil Lindberg, and I'm chairing this session of 3 talks, and I'm also giving the first talk. I am a member of the Engineering Processes and Tools section here at the Applied Physics Lab. We are basically the sister organization of the XRCC. I'm not actually part of the XRCC, but my background is in CAD tools, and I've worked into the connection between CAD tools and XR. While I am giving the talk today, James Dean is actually my co-author here, and I told him maybe we should swap our presentations and see who would notice, because he'll be giving the last talk in this, and I'll wait for a proper introduction for him later. Meanwhile, do I have anything else we need to do before we get started? I don't think so. Well, I will at least note our other 2 talks. Blake has been a big part of both of those, though he won't be giving them. And both Blake and James, I think, will be available for the questions that come out of my talk and the other talks. I'll be discussing today XR applications for spacecraft fabrication with Vufoiria Studio, which is a mouthful to say. I get into the XR side of the world not from the cool pictures and the fun games, but at the how do we actually do something useful with this. And in particular, I care a lot about the spacecraft fabrication and assembly side of the world. So James and I spent a lot of time looking at how can we help technicians in clean rooms do their jobs well, in particular when you have partially completed hardware and you want to see where the rest of the design will really fit in, but oftentimes the rest of those design pieces have not been fabricated yet. This is an ideal application for augmented reality. In particular, we're going to look at how we can actually enhance a return on investment in this kind of environment. And we're going to look at the pain points. We had a few pain points, and manage expectations so we didn't overpromise to what we could do. And we'll take a look at some of the trade-offs we had to make along the path with this. Quick overview of our problem to solve, the resources we had, how we approached it, the challenges. There were several. What we learned, and a lot of this is going to be video and photos. In particular, I will note, I have very trimmed down video segments that are used for this presentation, but I went through our public release process with a much larger video that I'll be sharing on a loop in the room next door from 3 to 5 p.m., where you can see the presentation experiences I'm using here and see them firsthand. I encourage you to take a look at all of the demonstrations and exhibitions in the room next door. Let's see, a few other words. I am making use of tools from PTC and other vendors, but I'll just give the usual disclaimer. I'm not here to sell, promote, or denigrate anybody's tools. We're just sharing the experiences we had using certain tools. Some things worked, some things didn't. They may or may not work well with you, but we're a nonprofit, so we use everybody's tools pretty evenly. In particular, our view in this world is wiring harnesses. All of our spacecraft tend to have very complex mechanical structures, and the wiring harnesses have to go from place to place, from instruments, power, control portions. Managing those wiring harnesses, fabricating those wiring harnesses creates a lot of problems in the clean room environment. In particular, one of the things I'll show, every one of these wiring harnesses needs a fair amount of hardware to hold it down. Tie downs and standoffs. This is the various hardware that the harness is attached to within the spacecraft. Figuring out where those go and managing them during the assembly process is a fair amount of effort. So we're going to use augmented reality to see exactly how existing hardware and hardware that has been designed but does not yet exist can work together and do so in a convenient way that actually makes sense for the technician today. This is a quick view of Bay D of the IMAP fixture. There are 6 of these bays that go into the circle to hold basically all the instruments and control, and obviously a lot of wiring harness. In the clean room, they actually build 6 of these fixtures that are just temporary fixtures to integrate the hardware, to work out all of the details that come along with the wiring harness. So yes, we get a fixture on a set of wheels. Obviously, the final spacecraft, all the bays are together, but this is in the environment we're looking at where a technician actually has to get the wiring harness work done. We had a number of tools available for this project that made sense to work with this. This is revolving all around the PTC family of tools. ThingWorx Foundation, this is the software platform underlying PTC's Internet of Things structure. It is closely integrated with the Vufoiria Experience Service. This allows published experiences to be viewed by supported devices, things like HoloLenses and iPads, both mobile and wearable devices. Vufoiria Studio, this is the user-level authoring application to create and publish experiences. And Vufoiria View, this is the viewing environment that actually runs on the user's end device, such as a HoloLens or an iPad. These tools are pretty well integrated together, but I will note PTC has purchased both into ThingWorx and Vufoiria. So there's several places I wish they were better integrated, but it's obvious they came from different software traditions, and PTC continues to work on helping them to work and play well together. A view of some of the targeted devices, and I'm kind of getting ahead of myself here. I wanted the HoloLens, the device on the left, okay, typical AR goggles we've seen, great way to visualize hardware that exists and designed hardware. It comes with some limitations in performance and memory that meant the model targeting mechanism I wanted to use didn't work as well as I had hoped it was. The iPad and iPhone platform, as it turns out, ubiquitous. You can get these things anywhere, they're readily available. Turns out, for the kind of experiences we're doing, they work pretty well. They display things, they map things pretty well. And you'll see how this worked out for our particular situation. So what we had hoped to do was put 3 basic areas together. The ThingWorx and Vufoiria infrastructure, which we had already built in place at the lab for other work. Model targets. Model target is the concept of an augmented reality device looking for a specific model, and once it finds it, to latch onto that and augment other details based on the authoring of the experience. And the HoloLens, Microsoft's augmented reality goggles. We got 2 of these 3 to behave well. So a quick view of what I mean by model targeting. And I will note PTC has a nice demo that they've used at trade shows for several years now, and I asked them to bring it with them. If you go to PTC's demo desk next door, you'll be able to see this. And it involves a toy motorcycle and the idea of taking a phone or a tablet, aiming it at the motorcycle, and outline appearing. Once you align them, it latches onto it and adds augmentations to it. And another view, this from an assembly point of view, which is the reason I like this one for our own application, of a technician working in the middle of, in this case, looks like a gearbox, and seeing where the part they're about to assemble next is going to go, and seeing it in real time. This kind of real-time feedback is very useful for technician clean room environments. So a quick look at where we started, which is Vufoiria Studio. This is the authoring platform. And the big story I want to get across in this for how we made this successful is that within Vufoiria Studio, there's really 2 fundamental models I'm bringing in. One is the model of the augmented reality I want to display. So in my case, it was things like all the tie down and standoff hardware. And in some of our views, I actually include the wiring harness itself. The other model is the model used for the targeting itself. And when I started down this path, I thought, okay, this is going to be easy. I'm going to pull in the basic model of the fixture, and it'll target on that, and life will be good. I can display whatever I want to. What I quickly discovered was the complexity of the targeting model, okay, which is the model you don't see, has a lot to do with the user's perceived performance. In particular, what I discovered was the targeting model heavily decimating that model, and I mean heavily. I started with some decimation techniques that perhaps might lop off 25 or 50% of the model. I discovered the performance was not really improving the way it did, and it wasn't adding anything to the experience. I started doing things like removing 90% of the model's detail, and I discovered that targeting works great. It latches on quickly, it recovers targeting quickly, and it's very tolerant of things that aren't in the model. In a fabrication and assembly environment, you oftentimes have incomplete hardware or hardware that has other stuff in it while they're working on it. A heavily decimated model target simply ignores those details and focuses on the larger effort. That was one of the surprises I got out of that, and it's what made this actually work well for the users. So now I'm going to go to the video portion of this, and apologies on how I do this. This is not the way I authored it, but the way we have to display things here, I had to change my video mechanism. So I want you to pay attention to, this video comes from the clean room here at APL, is how quickly we acquire the model and reacquire it when a device, for example, drifts the wrong direction or something gets in the way and the experience has to reacquire where it is. And in our case, the technicians at work had tools and things they had left behind inside the fixture. And when I first went to the clean room and saw all the extra stuff, I thought, oh, I got to get rid of that to make sure my model is clean. And I said, nope, leave it there. This is realistic. I want to see if the target can acquire the model in spite of the fact that some tools are sitting there. And the other one, I haven't talked about this much yet, but occlusion. So when I'm augmenting certain details on top of a physical structure, as I move around, certain details should no longer be visible. Of course, augmented reality, it doesn't care. It'll display stuff anywhere. I need to tell it where the model edges are so that when I go around the corner of something, the wiring harnesses no longer should be visible, truly disappears. And getting occlusion to work well went a long way to making sure that the experience was realistic and gained the trust of the user. Let's see how video goes, shall we? Hey, it's working nicely. Here I am in a clean room, and that was the model target. And you'll notice within moments of pointing at the fixture, it recognized it, kind of lit up, and then augmented, in this case, standoff hardware. And notice I kind of focused, and then it jumped back in after losing tracking and came back. Notice I have soldering hardware in the middle of that. Obviously, that's not part of the model. A heavily decimated model target says, I don't care. I know where my structure is. I will keep augmenting. And I didn't get a chance to show you, but as I went past this little rib in the middle, the standoffs on the far side of it disappeared, and on the near side of it, they reappeared. And in spite of the fact that we have a partially complete harness inside of here and another opportunity to reacquire, it correctly models all the hardware in the correct spot and makes sure the hardware you can't see truly disappears at that moment. And several moments in there where I was so close to the fixture that the tracking got lost, but it reacquired. And now we're going to take a look at the harness with a slightly more complex version of this experience. Note that I have full wiring harnesses, including bulkhead through fittings. And once again, I've got a work light over on the other side. It ignores it. And as I go around the corner, the back side, yes, those fittings on the back side, that's augmented. That's not physical. Even though some wiring, temporary wires are hanging through that opening, the experience continues to work correctly. This is from the other side of the fixture with a technician pointing at temporary things they left behind. Even going underneath, all of those wiring pieces underneath are augmented. They are completely out of the way and invisible until you crawl underneath the fixture. And completely designed wiring harnesses layered on top of incomplete technician work. And I loved this one where that little extra connector on top that had a gap between it, the modeling correctly picked up the fact you could see a portion of the connector before you went over the top to see the rest of the connector. I was very pleased with how Occlusion worked on this to get a very complete view of the model. I had to cut this video off to keep the length long enough for this setting. More details will show up in the video in the demonstration and exhibition area. And a close-up on one of the occlusion samples I really liked, where I've got both a bundle of cables from a through fitting and then a set of cables mounted on the back of the fixture. Both of them clip off correctly around the opening and maintain the correct location, even though that physical model is not what's doing the occluding, it's the logical model. So the HoloLens is where I wanted to be. The demos I just showed, this is all iPad oriented. The HoloLens is a great platform for an AR experience, and it's still my preferred direction to go for this sort of thing, particularly for a technician who might want to see it right in front of their face in a wearable environment. But I also discovered the technicians were perfectly happy with the idea of an iPad, perhaps on a tripod, as a reference for where the hardware would be in their clean room environment. What I discovered there's quite a few performance bottlenecks with model targeting that make the HoloLens a challenge at the moment. We're working on improving some of our techniques to get it to the point where a HoloLens is a usable experience. We were able to get it to successfully track, but the delays in latching onto the model and the difficulty with reacquiring meant it was nearly unusable in a technician setting in a clean room. And as I mentioned earlier, model targets, you've got to be very careful how you decimate them. And as I discovered, really heavy decimating. If you were to look at that model, you'd discover it's actually pretty ugly. But for targeting purposes, it's okay to be ugly, and that ugliness promotes a consistency of latching and a higher performance experience for the user. So the user doesn't see how ugly the model is, but they see the performance benefits of it and how they do see the high quality augmented model. A few more words about occlusion. Yes, spacecraft environments, it's complicated. There's a lot of different sets of experiences and expertises at work in any one of these. Making sure that it looks realistic when we're done, that the physical structure that's in the clean room, as well as the designed elements that we are augmenting, appear to be seamless and appear to work correctly, go a long way to assuring a technician using it that the results they're getting are accurate and worthy of their trust. I will make a note, this is something we are still working on. I was surprised to discover that occlusion behavior appears to be inconsistent across display platforms. In particular, the settings I used to get the occlusion behavior that worked well for the iPad did not work the same way on the HoloLens. Now, the way I understand how the Vufoiria engine works, it should be consistent, which tells me there are some inconsistencies in how those platforms are implemented in this software setting. So if you're looking at some problems like this, do be aware if you're targeting more than one hardware platform, you may discover some inconsistencies that affect how you implement this. So, a few lessons learned along our path. Model targeting is really powerful, particularly for hardware-centric environments. Our next plan after this conference is to implement more of the bays. When we first started this project, Bay D was the only one that existed and was in one piece to demo with. Bays A through F are now all available. When looking at a project like this, in considering what's actually useful for the technician in the field, overall device performance and what you're hoping to get across to the end user, you got to consider that up front and be willing to give things up to get a memory size and a performance situation that's usable. In other words, getting a lot of pretty pictures that may not be really useful isn't worth it if the technician says, well, this isn't adding value to my life. One we did discover, I didn't spend much time on this particular presentation for this. I have some pull-down menus that you can see in the demonstration area that allow us to display more than one set of augmentations within a given fixture. Turns out the automated menu structure which we used, very convenient, it's only available for mobile devices, things like iPads and iPhones. The same menu structure, for some reason, has not been implemented for the HoloLens. If we were to expand this to multiple platforms across multiple programs, which is our ultimate goal, dealing with things like, I want consistent menus across all applications, we're going to have to deal with that. I suspect there's a way to write custom code to deal with this, but I'd rather use the built-in functions within Vufoiria. And correct occlusion. When I headed down this path, I thought, oh, occlusion's just going to be a cool little detail we throw in the end, and that's it. It wasn't. It was a fair amount of effort to get it to behave well, and it ended up adding a lot to the overall experience. To see the details you don't like disappear as you went around the corner, you know, that's your confirmation. Oh, I don't have to worry about, oh, is that stand up on this side of the plate or this side of the plate? Nope, if you can see it, it's on your side of the plate. A believable augmented reality experience gains the user's trust. And I put that at the end this way because that's not one of the final developments I would have expected out of that effort. But I know one day I ended up down in the clean room once again. A couple other technicians were working on other bays, and we put them in front of this experience, and their faces lit up when they said, wait, it really does do that? I really can see this? It's like, okay, that's that aha moment where you realize XR has value in a hardware-centric assembly and fabrication environment. It's the end of the presentation. However, I had more pictures, and part of it was I wanted lots of pictures to be signed up for public release. So detailed standoffs on the bottom side of the fixture I thought were really cool. They showed there were a lot of this fairly complex bracketing going on down there, and it just worked. Also, a shout out, remember that decimation I was talking about? There's a lot of decimation tools out there. We happen to use PTC Studio. It made it very easy. This is from the run I used for that final model target. And you'll notice there's like no details at all left on that thing, but it still picked it up, it ran with it, it was very accurate and very quick. So this tool actually worked for quick decimation of complex models. And Adam Fagan up here is far more of an expert on that than I am, and he helped me get good results out of this one. And one of my favorite harness views, just because it shows multiple levels of occlusion, wire bundles, and different places things are attached, yet it all flows together with the physical fixture. That's the beauty of augmented reality for hardware environments. They all just fit together in a way that's immediately intuitively obvious to the user. And more harnesses. Oh, and standoffs sticking out from sides around existing bundles, showing you exactly where they go. This is the kind of thing technicians have to deal with on a daily basis. And that's all I've got. And I've got about 4 minutes left for any questions. Blake.
So I noticed when you showed the video, the synthetic model placed on top of the video of the real model completely occluded it, which meant that just based on what I could see on the iPad, I couldn't tell if maybe a fixture had actually been inserted underneath because I couldn't see it. Is there a way to like manage transparency so that I can get a better view of what's actually in place?
Yes. Now you're talking when it first layers up and then it disappears. So that's built into the model targeting mechanism, that it lights up your target just to let you know it's latching on, then it disappears.
Right. But then when you overlay a model on top of it, maybe one of the wiring harnesses or standoff, that standoff is a solid color. So
that's true. Yes, we can change. I believe there is basically a density setting on those.
Okay. Yeah, at that point, the interface actually requests you to write JavaScript code to do that.
Okay.
Yes.
So, in regard to the HoloLens, I mean, did you do any experiments to understand, like, is the device just fundamentally limited? Like, is it the LiDAR that's the limitation? What is it about?
I seem to be on the barest edges of its memory and performance. It would work, it was just painfully slow.
So, like, say if you stripped it way down to just one or two models in the experience,
Yeah.
and was it still slow, or?
The testing I did at that time, I couldn't get it to the point that it was really usable, and we were on a timeline crunch to support IMAP, so we opted to stop our HoloLens work and continue with the iPad just because we had initial good performance off the bat out of it. I do want to circle back and see if we can't do some software things to improve the HoloLens side of the world. And there's a side of me in the back of my brain that hopes Microsoft resurrects the idea of an HL3. We'll see.
Because just one comment, I went to the PTC conference this year and they had a lot of different displays of this product, and they did not have a single HoloLens on the floor. Like, they weren't even, PTC wasn't even, like, I talked to people and they weren't even talking about it. They chose not to even. So I'm kind of wondering, do you guys know, are they gonna, do you see that going away?
Okay, personally, I don't see it going away just because it's so useful a platform. Yes, in spite of the fact that Microsoft laid off the MRTK team, that they've dropped all their announcements for HL3, the platform for industrial settings, the $3,500 price tag, does not scare me for that setting. It's too useful a platform to disappear. Now, I have personal thoughts that maybe Microsoft used this opportunity to say, let's see what Apple does with Vision Pro and maybe adapt our plans in the future from that. So, because otherwise one could imagine a situation in which Vision Pro is coming out the same time HL3 would. And I can imagine some people at Microsoft saying, yeah, that's just not a good situation to be in. So I think the platform has a future. It's fuzzy at the moment. And you've been very patient, yes.
So to your comment here, it's not going away.
Can I quote you on that?
And it's continuing on. But you know, you talked about decimation and the need to go down that path. Have you worked with streaming at all?
With
Server-side render and streaming?
I have not, no.
So you can quote me on that. I'm a Microsoft director previously, and we were at the IBIS lab.
Okay. I like the HoloLens platform. That said, I also like multiple vendors to be competing in a space to improve all the products.
I think it's good for the industry to have many but you can also render 200 million poly models.
With that, I am tight on time, and now I'm going to put on my session chair hat to say, in general, we're trying to hold questions to the end of each talk, and all of our presenters today will be available in the demonstration and exhibition area next door. So please, if you have more extensive questions, come see them then. And in particular, I will be demonstrating this at the table next door.